Good morning everyone. Today I am going to explain the three important concepts in a compiler design, that is LALR of K grammar, error recovery in passing ambiguous grammars. These three topics are very important in a syntax analyzer and parse constructions. First, let us start with a LALR grammar. LALR stands for look ahead left right parser. It is modified version of a left right parser designed to reduce memory usage while still maintaining a powerful parsing capacities. In compiler design, LR parsing are very powerful, but they often create a very large parsing tables. To solve this problem, LALR parsing combines similar state and creates smaller parsing tables. This makes LR parsing more practical and efficient for a real compiler implementation. LALR parsers usually use one look ahead symbol, so most commonly we use LALR of one parsing. One major feature of a LALR parsing is that the merge of LR of one items set having the same code. Because of this merging process, memory usage and becomes as much smaller compared to canonical of LR parsers. LALR parsers are widely used in a parser generator tools such as Yak and Bison that we already seen in the last PPTs. Many programming languages include C and Java using LALR parsing techniques internally. So let us see the construction steps of a LR parsing. First we construct the augmented grammar. Next we compute LR of one item sets states. Then computable states are merged together from the LR of states. Finally, action and go-to parsing tables are created. Now let us discuss the advantages and the limitations of an LALR of parsings. So, the smaller parsing tables, efficient memory usage and more powerful of a LR of parsing, these are the advantages. Coming to the limitation is some grammar that can be parsed by full of LR of one parsers may create a conflict after stage merging in a LALR of parsing. Still, LALR parsing provide a very good balance between the power and the efficient. Now let us move the next topic called the error recovery in the grammar. So the during compilation programmers may make a syntax mistakes. If the compiler stop and finding the first error, it becomes difficult for the program to correct all mistakes. So error recovery technique help the parser recover and errors and continue processing to identify a more error in a single compilation. The main goal of the error recovery is detect syntax error, report meaningful message, continue passing after recovery. Now let us discuss some common error recovery techniques. The first technique is a panic mode recovery. In this method we pass the until find the synchronization and token such as the semicolon or closing brackets, etc. The pass level recovery are very important of the correct error locally inserting, deleting or replacing the token. The second technique is a pass level recovery. Here the parser tries to correct errors locally by inserting, deleting or replacing tokens. This method is more accurate but slightly complex. So the third technique is error prediction. This approach, especially grammar rules, are added to handle the common programs mistake gracefully. So the error detection occurs when the pass encounters an unexpected token in the passing tables. So the good error reporting should clearly mention the location of the error, type of the error, possible corrections of the information. Now let us move to the final topic called parsing ambiguous grammar. In the parsing ambiguous grammar is a grammar that can to generate a more parse of the some input strings. In simple world, the compiler becomes confused because multiple interpretations are possible. This ambiguity creates parsing conflicts such as the shift reduce conflict. reduce conflict. Ambiguous grammars are a common international language and sometimes appear in a programming language constructs too. Now let us discuss the method to handle the ambiguity. The first method is a grammar refactoring. Second one is a disambiguation rules. So the first method of a grammar refactoring is the ambiguous grammar is rewritten into an unambiguous form. The second one is the disambiguation rules. Parse generators can use precedence and associativity rule to choose the correct parsing actions. For example, multiplication has a higher precedence than the addition. Operator may be left associate or right associate. The third method is using GLR, generalized left-right parsing is a GLR abbreviations. These parsers can explore a multiple parsers tree simultaneously and handle the ambiguous grammar effectively. The another method is a selective parsings, where ambiguous or manually resolved or restructured. To conclude this today, we discussed about the LALR parsing, error recovery parsing, and parsing the ambiguous grammars. These concepts are very extremely important in a compiler design because of they help a compiler parse programming language efficiently, detect the syntax error intellectually, then handle the grammar ambiguous effectively. Thank you all. Thank you once again.